So I have this launcher opened over here, and it is desired to select the double precision always. And if your particular desktop or laptop or workstation is having multiple solvers, then you can just enhance the list over here. That is by increment of these numbers, or else you can just go with one depending on the case. Now, since we are dealing with a coarser mesh and very simple cases, so I believe one processor is enough for my system to be loaded with. Now, I will just click on start over here and wait for the setup to open. Here it is. And you can see that the Fluent always gives this default window. If you do not want to read this message, you can just click over here and press, so that the next time you will not be reported with that message. Probably that is reflecting the changes with respect to the previous version, and that is not of significant importance, especially with respect to simulation point of view. Now, as the flow velocity, what we are deciding for this case will be approximately 1 meters per second. All right, so I will be going with pressure based numerical solver, and it is not required for us to go with density based, right? And I'll quickly go to the models over here. In the viscous model, I will be selecting K epsilon with standard and standard wall functions, and I'll just press OK over here. And after that, I'll just minimize this models and go to the materials available over here. Now in the materials, I will be selecting air at first, and here we will be deciding the material. So we will not be going with air material, and we will be going to the Fluent database. And right now I will be simulating a gas over here. So I will be considering propane gas. All right. Now propane is a kind of gas which is having multiple applications. I have opened in this window over here. You can see that there are several uses of propane gas in the industrial sector as one of the most versatile energy sources, right? So this gas is basically used to generate energy. I mean, it is a kind of energy source, and you can just Google and just try to catch up and understand what are the different applications of propane gas, right? So we're not bothered about the application because our simulation is very simple. But imagine, you're transporting a propane gas in a pipe. All right, and this is the pipe shape. Okay, the propane gas is passing from left to the right, and we are just investigating the flow field of propane gas. Clear? Now I need to search the propane, so it will be alphabetically listed. I am in P right now, so you can see propane over here, C3H8, and the density is 1.9 kg per meter cube. If you remember, the density of air is 1.225, so it is little bit uh, denser than the air. Okay, little bit, kind of 0.75 kg per meter cube increment. Now to add this material in this material list, we simply have to click on copy, and you can see the propane is being added in the background. Now the next task is to simply close this, and you can just close this as well. The propane is being added over here. Now, if you remember, in the previous project, we have entered into cell zones and selected the respected zone and edited it, or double clicked on this one. This is because we have to assign the material as propane. Only the addition of propane in the fluid in the material list doesn't mean that from the inlet the propane is supplied. All right. So we have to select it from here and click apply and close over here. If you want, you can just double click and verify this whether propane is selected or no. If you want, you can just reapply and close. Now we are entering into the boundary conditions. We have inlet X, we have inlet Y, then we have the interior, that means the interior region of this particular domain. We have the outlet and the wall. Now coming to the inlet, I will be assigning a velocity of inlet that is 1 meters per second, and just click apply and close. On a similar note, I will be applying the velocity for y direction as 1 meters per second. So we have propane gas entering from two regions and exiting at one entry. Okay, I'll just click apply, and close. So we have the outlet, that is the pressure outlet by default, and the operating condition is 101.325. Clear? Press OK, and you can now move to the reference values, and from the compute you just have to select the inlet X as of now. Okay, and you can see the density being listed over here. Go to references and just select the preferred zone what we have. In the method I will be using the simple method, and we can just go with high order term relaxation, and if you wish you can select second order upwind schemes. Now I'll just go to initialize directly and click on standard and compute from inlet X and click on initialize. Now I'll just go to run calculation and enter 500 iterations. And also if you want, you can just increase the convergence criteria to something 1e minus 4 or lesser than that. Since we are just performing a conceptual study, so we can just keep the default values or a little bit decrement in that. After that, I'll just click on calculate and wait for the iterations to start. And when the iterations are starting, I'll just pause the video and close this video so that we can just discuss in the next video as to what has happened for the flow simulation. And we will also see the velocity contour in a cut section plane in the Fluent module itself, and we will see how the first the propane gas from first inlet is interacting with the second, and they are just exiting from the outlet. When this is completed, the next job will be to perform the DPM analysis, that is discrete phase modeling, and that is very simple. I mean, it looks complicated, but when we are working on it, I believe we can understand easily. So I'll just wait for it. Yeah, there it is. The simulation has started, and let me just pause the video now, and let us just meet up in the next video.